Hello friends, you are on the PRO Machines channel. My name is Anthony, and in this video we will talk about methods of profiling rolled metal. Profiling is the process of giving metal a certain shape and size using special machines and tools. Basically, all profiles in cold rolling mills are formed using the sequential profiling method. The essence of this method is that the metal acquires the desired geometry gradually. Entering the first stand, the flat sheet begins plastic deformation and acquires the first bends in one or more places, which are not yet similar to the final result. But each subsequent stand in the rolling mill continues to bend the formed corners as intended by the designer until the desired result is achieved. Depending on the type of raw material, its yield strength, thickness, parameters of a specific bend, the length of the bent shelves, the designer can assign a different number of transitions to form a bend. Each transition is a separate profiling stand, with its own shafts and rollers. For example, if the metal is soft, plastic, then the attack angle at each transition can be made 22.5 degrees and form the desired bend without defects in 4 transitions. But if the metal is hard, with such an attack angle, diagonal breaks will form on the surface of the metal. Therefore, the designer, having the initial data on raw materials and a drawing of the product, must correctly calculate the number of transitions for each angle in this product. If the metal is hard, then in order to bend the strip by 90 degrees, you need to reduce the attack angle, for example, by half, to 11 degrees, which of course will increase the number of transitions to 8. You probably already know how to determine the rigidity of the metal. This can be determined by the value of the yield strength. The corner radius also has a strong influence on profiling. Here are some aspects in which the corner radius plays a key role. 1. Form accuracy. The more precisely the radius is set, the more precisely the shape of the resulting profile will be. An incorrectly selected radius can lead to deformation. 2. Uniformity of load. The correct radius helps to distribute the pressure evenly along the entire length of the bend, which prevents local overloads and deformations. 3. Minimization of stress. A smooth radius reduces stress concentration in the material, which is especially important to prevent cracks and tears, especially when working with brittle or hard materials. 4. Aesthetics. The corner radius is also important for the appearance of the product, especially if it is used for design or architectural purposes. 5. Material applicability. Different materials may require different bend radii due to their different yield strengths and tensile strengths. 6th. Specification. Compliance. Certain products may have strict bend radius specifications. Typically, calculations are performed to determine the optimum corner radius, taking into account the thickness and type of material, as well as the end use of the bent sections. Using computer modeling can also help determine the best radius for a particular application. Corner radius can significantly affect the number of passes required to bend metal in a rolling mill. Here's how. 1. Smaller radius. If metal needs to be formed with a smaller corner radius, more passes will be required because the shape change must be made gradually to avoid damaging the metal. The thinner the metal and the smaller the radius, the more small incremental changes are needed. 2. Larger radius. A larger corner radius allows for fewer transitions because it is easier to form and less susceptible to damage such as cracks. As a result, the metal can be bent in fewer operations. 3rd. Progressive deformation. Complex shapes with a large radius may require specialized intermediate transitions to ensure progressive deformation without damaging the material. 4th. Roller tooling. The radius determines the amount of curvature of each roller. If the radius is large, fewer rollers with a more gradual curvature can be used. Smaller radii require smaller, more frequent curvatures, which results in a larger number of rollers. When designing a roll-forming process, engineers consider potential issues related to radii and adjust the process to minimize risks and ensure a high-quality, efficient bending process. This may include computer modeling and testing to determine the optimal number and configuration of transitions. Also, depending on the profile geometry and the design task, the designer can apply different effects to the metal with rollers to bend the angle. Now on the screen, you can see different options for bending the angle. 1. Constant developed length method. While the developed length is constant, either the angle is preset and the radius is calculated, or the radius is preset and the angle is calculated. 2nd constant radius method with compensation of the previous segment. While the radius is constant, the angle is preset and a new length is calculated. In order to keep constant the sum of all lengths, the length of the previous segment is modified. 3rd constant radius method with compensation of the next segment. The same as method A2, but instead of the previous segment, the next one is used for the length compensation. 4th, constant radius method with compensation of the previous and next segment. Combination of A2 and A3. How much of the surplus length should be added to the previous segment can be preset. The rest is added to the next segment. Track holding method. The surplus length is divided automatically to the previous and next segment, that the strip is guided straight away with constant intersection point of the tangents on the inner or outer side. 5. Angle radius method for spring-back compensation. More material is bent than necessary. The part that is bent too much is pressed to flat again. Because the partial arcs spring back in opposite direction, the effects negate each other. This method is used by experienced designers for spring-back compensation. Calculating the spring-back. When the finished bent profile leaves the last pair of rollers, the walls of the profile bounce. This spring-back of the profile is calculated depending on the material, the sheet thickness, and the radius and angle of the bend. It can be selected for a single arc or for the entire profile. The drawing can be shown in a loaded or unloaded state. This will determine the shape of the rollers. At least the last attacking rolling tool must be designed for a loaded state to compensate for the springback. But not all corners must be bent in turn. Often, 2 corners are bent at once if this is possible. Again, the designer decides this. That is, you see what an important role the designer has, who calculates the profiling. You can get an ideal machine from the point of view of mechanical engineering, but if the profiling is calculated incorrectly, then there will be problems with rolling the strip. And we talked about all this about the method of sequential profiling, which is used for the vast majority of products, including for corrugated sheets. In such profiles, the bends begin in the center and form 1 or 2 waves at once, then 2 more adjacent ones, then another, and so on until the end, until the product is ready. Since in this method the metal always remains free from the edges, nothing prevents it from being pulled to the profiling site. And if your machine is made in the best traditions of mechanical engineering, and the designer correctly calculated the profiling and the number of transitions, then you will have an ideal machine for a specific type of product and specific parameters of raw materials. It will produce products of very good quality. The accuracy of the geometric parameters will be maximum. There are programs for calculating profiling that, based on a mathematical model, can show the best profiling option as well as places of high stress concentration, due to which rolling defects can form. For example, the profile can go like a screw, bend like an arc, a sickle or a bulge can form. Or the profile shelves that are parallel in the drawing may in fact be somewhat non-parallel. And seeing such places with excess stress, the designer must take countermeasures in order to get high-quality rolling. Automatic creation of the flower pattern scheme significantly speeds up the design of roller tools for repetitive profile types. The necessary knowledge is taken from a database that is constantly updated as the system is used. When a new profile needs to be designed, a similar profile from a previous project that was successfully produced is usually used. The flower pattern and roller tools are modified according to the shape of the new profile. The results can be verified using quality management tools, calculation of the stress at the edge of the strip, analysis of the stress of the profile, or the virtual machine for roller forming, which simulates the process of roller forming using the finite element method. If the manufacturer has such programs and paid for updates, then in fact the company has a database of profiles and the successful experience of other companies. But of course, in order to correctly use this knowledge, to be able to correctly configure the program for solving a specific problem, the user of this program, i.e. the designer, must have experience in constructing profiling, know how and why it is necessary to apply one of several methods of bending corners here. This concludes the sequential profiling method and moves on to the parallel method. And this is what you can mostly find on lines for the production of corrugated sheets with a low corrugation height. Its essence is that the metal strip entering the first stand of the rolling mill is subjected to simultaneous deformation along the entire width, and all the corrugations rise simultaneously. And from here follows one of the main disadvantages of this method. The metal has nowhere to be pulled to the center or to the neighboring corrugations. As a result, the raw material is subjected to strong multidirectional pulling loads, because each corrugation tries to pull the metal to itself, while the factor of internal stresses in the metal, which are formed during rolling at the metal plant, is also imposed. As a result, the diagonal of the finished product may go beyond the permissible values, 1 to 2 millimeters per linear meter, but not more than 4 to 5 millimeters for any length of the product. This happens because the metal strip is not uniform in thickness. In the middle, it can be, for example, 0.45 millimeters, on the left 0.39, and on the right 0.43 millimeters. And since all our corrugations rise at the same time and there is a struggle between them to pull the metal, then those corrugations win where the metal thickness is greater. In our case, this is the center and the right side, which means relative to the left side, this is all completely the right side. and therefore all the metal begins to pull to the right, because the gaps between the upper and lower rollers are the same on all corrugations. And the third method, I call it combined, someone else calls it. But the point is that here at first a central corrugation or several are formed, as in the sequential method, and then everything is as in the parallel method. All the corrugations except the central one are formed simultaneously. This essentially solves the problem of the parallel method, because the central corrugation formed at the very beginning is designed to hold the profile in the center with rollers in the next stands. Of course, another question is how often you will come across rolls with pronounced thickness differences. If you buy very good quality raw materials, which are produced using the most modern technologies, then this will probably be rare. Therefore, if you buy a machine that will produce trapezoidal profiles for a roof, fence, or a metal tile profile, then I recommend first of all considering the sequential profiling method. Next in priority is the combined method, and last of all, the parallel method. And if the supplier does offer you a parallel method, make sure that there are enough stands to minimize the negative effect of metal sliding to the side. I think that depending on the complexity of the profile, it could be from 15 to 23 stands. I'm finishing this video. Thank you for watching, for your likes and subscription. If you have any questions, ask them in the comments. I'll try to answer everyone.